Alright, let's just jump right in today. We're skipping the small talk because we have a massive, and I mean literally massive topic to cover. Get ready, because we're embarking on an immersive, chronological journey into the absolute greatest unknown in the universe. We're looking at the ultimate cosmic drop, but falling into a black hole isn't just a physical journey. It's a one-way ticket to the very edge of where our known laws of physics even make sense. So let's not waste a single second.
Seriously, I want you to picture this for a second. What would actually happen if you fell into a black hole? Just imagine it. You're out there in the freezing vacuum of space, drifting closer and closer to an abyss so incredibly dark and dense that it consumes absolutely everything. This isn't just some sci-fi movie trope. This is a very real, high-stakes hypothetical scenario that's deeply rooted in astrophysics. It is the ultimate one-way trip. And today, in this explainer, we're going to map out exactly what that descent actually entails.
Section 1. The ultimate cosmic drop, taking the plunge.
So, the descent begins as you take the ultimate cosmic drop. At first, you might just feel a really gentle tug, right? Just a slight drift pulling you off your original trajectory. But as you draw nearer, you're approaching what we call the Schwarzschild radius. That's the point where the very fabric of space-time itself is bending and warping around you like this giant, inescapable funnel. The tension builds exponentially. You're heading toward a cosmic boundary where the current of gravity is about to become so overwhelmingly strong that the fundamental rules of motion just begin to warp.
Section 2. The event horizon, the first boundary.
The event horizon is the critical boundary of a black hole where the known journey shifts. Simply put, this is the point of no return. The physics behind this is actually pretty straightforward. At the event horizon, the escape velocity exceeds the speed of light, and since nothing can travel faster than light, absolutely nothing escapes. Now, before you hit this invisible threshold, you're still in our universe, playing by the rules as we largely understand them. But here is the crazy part. To an outside observer watching your descent, you wouldn't actually seem to cross it. Due to extreme time dilation, you'd appear to freeze right at the edge, your image slowly shifting to red and fading out. Meanwhile, from your own perspective, you just plunge straight through, into the abyss.
Section 3. The spaghettification effect, physical reality.
Okay, let's break this down step by step. Step 1, you are officially falling into the black hole. You've crossed the threshold. Step 2, you begin experiencing an extreme gravitational pull. But because the mass of the black hole is so infinitesimally concentrated, you're subjected to immense tidal forces. Basically, the gravitational pull on your feet is millions of times stronger than the pull on your head. Which brings us to step 3. You endure the spaghettification effect. These extreme tidal forces physically stretch you out vertically, initiating what is easily one of the most violent and fascinating processes in the cosmos. A visceral, physical phenomenon takes hold here, and man, the reality of this situation is beautifully stark and incredibly chaotic. As you're stretched out vertically into a long, thin strand of matter, like a piece of spaghetti, you aren't just getting pulled, you're also undergoing intense lateral compression. Because the geometry of spacetime is converging towards a singularity, you are being fiercely squeezed horizontally at the exact same time you're being stretched vertically. You're literally forced into a microscopic stream of subatomic particles. It is just absolutely mind-blowing to understand how intense gravitational forces can warp physical matter to such an extreme degree.
Section 4. Knowns versus mysteries, the boundary of knowledge. Look, we have the math to back up the mechanics of the event horizon. We have the physics to perfectly explain spaghettification. We can trace this descent with concrete scientific facts and highly accurate models. But once you're stretched out and pulled toward the very center, the singularity, our current laws of physics literally break down. We just end up staring into an absolute void of understanding where the equations that govern reality simply stop functioning.
We're hitting the limits of current science here, looking directly into the great unknown beyond. Just like the black hole has a physical boundary, our scientific knowledge has a firm boundary too. The core issue is this fundamental conflict between our best physical theories. General relativity perfectly explains the massive gravitational forces at play, right? But quantum mechanics is needed to explain things at a microscopic, subatomic scale. At the singularity, you have immense mass crushed into an infinitesimally small quantum-level point. And right now, those two theories absolutely refuse to work together. We can calculate the plunge for sure, but the very bottom of that cosmic drop remains a barrier we simply haven't crossed yet.
Section 5. The mystery continues. Looking ahead.
One day we'll know, but for now, the mystery continues. And honestly, there's something profoundly hopeful about that. It means there is still so much left for us to discover. We're fully embracing this cosmic mystery. The black hole is like the ultimate puzzle, And while we've managed to put together the edge pieces, like the event horizon and gravity's physical toll, the center is completely blank. We're just waiting for the next great breakthrough in physics, perhaps a unified theory of quantum gravity, something that can finally marry the macroscopic with the microscopic and illuminate the dark center of these cosmic behemoths.
Stay curious, because every answer leads to another question. We figured out the event horizon, and boom, that just led us right to the staggering mystery of the singularity. If you take anything away from this explainer today, let it be that. Let the unknown excite you rather than scare you. We've mapped the edge of the abyss, but the center remains entirely dark. So I'll leave you with this. When we finally do crack the code of the singularity, what else about our universe will we have to completely rewrite?